Hello guys, I am Muhammad Ala from the Bright Light of Knowledge channel. And yeah, you know that before the episode even started. Don't worry, this is the third episode of my embedded system series. What are we gonna learn, you ask? We're gonna learn about breadboards. But before we learn about them, make sure to support our brothers in Palestine because there are certain attacks and they literally hurt the Palestinians. The Jewish are not the hurt but the ones who hurt themselves. So support the Palestinians. Always remember them, and remember your family about them. But let's get started now. Let me first share my screen. Share your screen. What do you want exactly? Don't care about him. He's just a stupid brother.
Wait, like,
Let me just delete this LED from the first episode. Let's get the Raspberry Pi Pico a bit away. Let's get a breadboard.
Wait,
As you
said-
can see,
you said you were gonna get a breadboard, but you got a half.
they're literally the same thing.
No, it's not.
He's just rude. Don't worry about him.
No, I'm not.
As you can see, breadboard is just a board with some holes in it. Like you might be saying, what's the point of even using a breadboard? Like, look, it's just a board with holes. It's not actually just a board of holes.
Inside it, there are metal pieces which connect electronics with other electronics. It's instead of using tape or soldering with your hands. Like if you solder and test it, and the device fails, you have to desolder and redo the connectivity. Then is there an easier way to test? Yeah, it's the breadboard.
This is called a solderless breadboard because you can insert jumper wires in it and easily get the jumper wire out without having any problems. But what? Ross, shut up. Let's see what the components of a breadboard are. First of all, we have the power bus. You can see a positive sign here and the negative sign. This is called a power bus. Each of these, the holes on the red side are connected to each other, and the holes of the blue side are connected to each other. The same with the other side. Here, the holes on the red side are connected to each other, and the holes of the blue side are connected to each other. And I'll show this with practical examples. And also, I'll make a circuit with using breadboards, one without the Pico and the other with the Pico. So let's proceed. But certainly, this is what I was saying. Power bus, the holes on the red side are connected to each other. The holes on the blue side are connected to each other. Same on that side. But this side is not connected to yours. What about the holes in the center, you ask? You see those? You see the letters like A, B, C, D, E? And see the numbers 1, 2, 3, 4, 5. Well, each one of these numbers has 5 holes connected to. Like if you connect 5 volts on 1A, which is this hole, 1B will get the exact same voltage. 1C2, 1D2, and also 1E. If I connect 3 volts at 1J, 1I will get the same voltage, 1H will get the same voltage, 1G will get the same voltage, 1F will get the same voltage. So every row is a separate row from what's above it. So every row is a separate row from what's above it, or below it, or across it. And I'm saying above or below because the breadboard is supposed to be vertical like this, but I'm just putting in horizontal so you can see what I mean. Each row is separated from what's above, from the above row, from the below, or from the row that's across it, or that's separated by this central line, I guess. Wait, why did I simulate? Let's show an example. Let's simulate it on the power bus. Once at the power bus and once at the normal holes. Let me connect VCC. Let me get a ground. Let's get some LEDs, because why not? Let's connect the first LED here. Notice I'm connecting this way because I've connected horizontally and might cause a short circuit, which can lead to the damage of the circuit. So connected like this, fellas. Let's make this yellow. Let's make this green. You know, traffic light. You know, LEDs, each LED has two wires, two terminals. The cathode, which is symbolized as C, and anode, which is symbolized to an A. A is connected to either VCC, either to the supply voltage, or to a pin in the pico if you want to control whether the LED is on or off. The cathode is always connected to the ground. And here's a special way. I'm gonna insert some resistors. Like this. Well, never mind. Let's not insert resistors for now. But resistors are crucial to not damage the LED. This is just a simulator. First, let's connect this this hole from the power bus. Remember, each hole of one of these is the same on the red side. Each hole on the red side is the same. If I connect this here and this there, this. Notice that I'm using the holes that are connected to the anode, like this. This anode is in this row, so I use this row. This one is in this row, so I use this row. Let's color them in red because why not? Let's color this yellow. Let's color this blue. Let me delete this code for a second because we won't need any code. Like, you tell me, why are the LEDs not turning on? They're connected to VCC. Well, they're connected to VCC, but he forgot to connect the other terminal, which is the cathode, or C, or the negative. Connect this negative here. Connect this other negative here. Connect this last negative here. Now tell me what's gonna happen. All of them line up. So that's how a breadboard works. Generally passes the circuit between the holes of the same row, like this row, for example. This is a row, and also simulates on the power bus. This is a circuit with. This is just an example. Now let's enter to the real circuits. Let me just delete all of these LEDs. Let me delete these wires. In a real life application, you would take off the wires, but since this is simulator, I'll just delete the wires. Let's get a push button. Put the push button here. Need a resistor. These are the components for this for the circuit. And an LED. What I want to do is let the push button, when the push button is on, the LED will turn on. When the push button is off, the LED will stay off. Let's do the circuit. The resistor here. Let's put the LED here. Or you know what? Let's put it here, for example. Let's put the resistor here. Now, what should we do to connect all of this? First, in the push button, there are 4 terminals, right? We need just one left terminal and one right terminal. This is an L terminal, L terminal 2, L terminal 1, R terminal 2, R terminal 1. Just need one left and one right. Let's connect VCC on this left terminal. So the push button activates when it's hot, when it's high. In the next episode, we'll learn about interrupts with push buttons. You will learn other concepts like pull down resistors and pull up resistors. But I'm sure you'll get the point. Let's connect this to the resistor, connecting to the same to the hole on this row. I could choose any hole I want. Let's choose this hole, for example. Now we have connected the push button and the LED. What about the push button resistor? What about the LED? First, we'll connect this resistor to the anode of the LED. Now we have one crucial step is to connect the ground with the cathode of the LED. The resistor that's connected to the push button is connected to the anode of the LED. Like as you can see. Here I have the supply voltage for the button. The button then is connected to the resistor. The resistor sends the signal, but slow down because the resistor resists the current a bit to the LED, to the anode of the LED, and the cathode is connected by ground. Let's simulate this circuit. As you can see, nothing happens. When I push the button, the LED turns on. Release, off, on, off, on, off, on, off, on, off, on, off. So yeah, if you have done this, then you're starting to get better at breadboards. Now let's make a circuit with the Raspberry Pi Pico. Delete you and you and you and you and you and also you. You're useless too. Let's connect the Pico like this. let's make the same push button to LED circuit, but using the Raspberry Pi Pico and some code. This time we won't need any resistors. Let's get a push button. So we got our push button. By the way, here's a bonus trick. If I want to connect the same supply of battery, but in the other side, just connect the positive hole with another positive hole, and any negative hole with another negative hole, like this. This isn't necessary, you don't have to do it, but it's okay if you do it. Now we need an LED. Let's connect it to this pin, and let's connect it to a pin that's next to a ground. This is a ground, which is transferred to the cathode like this, and this is GP27, which is transferred to the anode. Let's connect VCC to this terminal. Let's connect this terminal to GP0, which is pin 0. Now let's write some codes. From machine, import pin, from time, import sleep. Now we need to define our pins. First is our button pin. We'll type in button is equal to pin 0, and it's an input, so we'll type in pin dot in. Here's the bonus, and here's another bonus. It's pin 2. You want the button to be active high, right? It's supposed to be active when it's high. And even I connected the VCC to do so. But what you can do is initialize a pull down resistor. Pull underscore down, which is set by pin dot pull underscore down, which just means there will be an internal pull down resistor in the Pico itself that's connected to the button. The pull down resistor set the default to 0. Pull up resistor set the default to 1. Now for the LED. LED is equal to pin. Which pin is connected to pin 27? Type in 27. And LEDs are outputs, so we'll type in pin dot out with all capital letters. Now we'll type in our main loop, which is the while true loop. I'm gonna type in 3 ways to make the button adjust with the LED. First way is just an easy one. If button dot value is equal to 1, or just button value like this, then LED dot value set to 1. Else LED dot value sets to 0. We have to initialize a sleep here so that we don't use all of the Pico's power. We'll make it for 20 milliseconds or 0.02 seconds. If I press, works fine. When I press, it's on. LED is on. When I release, it's on. The LED is on. But that is just too easy and takes a lot of space. What you can do instead, the second method, is set LED dot value 1. We'll set it to 1 if button, if button value, else 0. This is a cool way to write an if statement. Let's see if it works. Yes, it works. On, off, on, off. But even that is not enough. The third way. We'll set the LED value to the button's value directly. Let's see if it works. Just like that. These are 3 different ways to let a push button's value set to the value of an LED. This is how to use a push button to turn an LED on or off using the Raspberry Pi and also a breadboard. Let's give recommendations to the breadboard. 3. The first way is the simplest one. The third way is also, all of the ways are simple, but you just have to understand them. I hope you liked the video, and see you in the next episode.